Welcome to Luca and Miguel. Enjoy the video.
You begin by preparing the environment and the data. Install NumPy and related libs, then load your CSV or array and verify shapes. This matters because matrix math assumes consistent dimensions. Once done, normalize or standardize inputs so gradients behave well, and split into train, validation, and test sets, typically 80% for training. Now, initialize weight matrices with small random values and biases at 0. This first practical step starts the model in the correct numerical rate. You implement the core computation, the forward pass and gradient formulas. Use NP. Dot for layer multiplies and apply activations like re-LU for hidden layers and softmax for multiclass output. This keeps things fast. Then compute the loss, mean squared error for regression or cross-entropy for classification, so you have a scalar to minimize. Next, derive and code the backprop gradients analytically, and vectorize them so updates operate on whole batches. This reduces runtime and numerical error, making training You run the training loop. Shuffle data, form batches, compute forward backprop, then update weights with gradient descent using a chosen learning rate. Make sure to validate after epochs and save model parameters with NP. Save so you can reload later. Once trained, evaluate on the test set to confirm generalization. If training diverges or loss stalls, check shapes first, then try lowering the learning rate, change initialization, or swap activations. This single troubleshooting tip often reveals the root cause.
Thanks for watching and please subscribe. It's the best investment you'll ever make.